the break, I got a lot of questions regarding the whole dynamic of Ubuntu Core. How do you use Ubuntu Core? Questions about provisioning of devices, questions about updatability of core, and so on. So I will add those elements towards this presentation as we go. If you have questions, please, again, let's save them for the end. But we can explore a little bit broader the whole portfolio that we have in IoT, despite the fact that today we're going to be talking about AI deployment of applications, okay? So let's begin. Let me start the timer. Perfect. So what we're seeing today is, I will not say a competition, an evolution into the deployment of AI applications to the edge, right? Most of you have seen how we're using it today in terms of cloud. It's easier to have it here in terms of latency, in terms of that actual response. That is what is giving companies that extra benefit, that edge. Think about all the small startups that today are trying to give you access to tools like ChatGPT on your simple phone without internet connection, on your smart home hub device, right? What they are trying to do is do all the inference here on the edge in order to win that responsiveness, right? You don't want the user to ask a question and wait for 30 seconds for your query to go to the cloud for you to get an answer. You want it to happen quick. And if you think about IoT devices and how they are used in critical infrastructure, sometimes that needs to be quick, right? If you're talking about industrial robots, you cannot have that lag, that latency. So this is why we start seeing why the edge AI market is growing. And this is just one of the many numbers that you will see about this growth in the market and how big is expected to be. We see startups working on this. We see even startups creating different CPUs, GPUs, TPUs, and so on. Everything for the easy processing of AI inference at the edge. Okay. And while you are probably either working in a company that is deploying models to the edge, or you are just interested on the topic, you will find that you will start facing three main challenges in terms of software life cycle, okay? We're going to cover those here in this presentation, and we're going to cover how you can use, again, tools that are available to you for facing those challenges. It's also important to mention that I'm not going to be talking about anything related about the training of AI models, trying to optimize them, trying to go through techniques like pruning in order to get models linear for the edge. That is a whole different field, and it's a really exciting field if you want to have a look at that. Here we are only going to cover those challenges in terms of software. And let's start with one of the important things, the security perspective. Why we care so much about security here at Canonical? We have millions of users using Ubuntu today. We have realized through our history that that makes us reliable if something happened to those users because we're introducing a security breach, right? We have to be cybersecurity compliant. And the moment that you are deploying devices to your customers, you are also going to be responsible of their cybersecurity. Devices that are on different industries running AI models are collecting data from your final user, but are also interacting with the facilities, with the hardware that they have in that specific industry. That gives them a bigger attack vector, right? Plus, when you are deploying your model to the edge, is your IP, right? The work that you put fine-tuning that model is now outside your company. It's outside your office. It's closer to a user. It's closer for someone to have physical access to it. Would you put your IP in jeopardy? That's another angle of why security is important. Let's go to the maintenance of that model, because we know that a good machine learning model is constantly being updated, constantly being improved. As people start testing it on the field, you know how you need to start fine-tuning the model in order to solve problem A that you saw with your deployment in the US. Solve problem B that is going to make your system better than the competition. It needs to be updated, right? Of course, if this is a data center, it's going to be much easier because you have access to the whole infrastructure. But if we're talking about IoT devices that are deployed in France, in Spain, in the US, in Asia, and so on, what are you going to do? Are you going to hire a team of IoT field engineers that are going to go to each of the devices and sideload updates? Are they needed? That is going to be expensive. All of these things you also need to start thinking from the get-go. Because the moment that you have picked your infrastructure, it could be too late for you to start making those changes. As simple as that. And a third point that is also important to mention, even if we're talking about constrained devices with low resources, AI models are heavy, especially this new generation of Gen AI models and so on. Take something as ChatGPT 3. Even optimized versions can get around the 100 gigabytes. 100 gigabytes. Think about that. Think about updating 50 devices with one application that is 100 gigabytes. Now multiply that for 100 devices or 1,000 devices. That is going to be really expensive in terms of your bandwidth, okay? So that is another extra cost that you have to think of when you are deploying your devices. How are you going to pay the internet bill or just the engineering time of someone sideloading that into your device, right? And connected to that is the packaging and the deployment of your model. When you're training your model, normally you will have your nice environment, and then you will start installing different versions of Pythons, trying and fight with CUDA, with different versions of CUDA, and then you have to start shipping that to your customers. And many more dependencies, OpenCV, NumPy, and so on, right? You need to find a consistent way for bundling all of those things to make it easy to send it to your different customers around the world. But also, something that is really important for us to understand is that the moment that you're making your software available to somebody is the moment that you're already showing to them what type of user experience you are giving them. If you are telling your user, in order for you to use my model, you need to first install this. Second, run this script. Third, if you have questions, go to this because probably you will have to go to the troubleshooting section. That is giving a bad impression of your company. That is giving a bad impression of your user experience, right? And this could apply to many of us that are right now, okay, let me use Docker, let me put everything in Docker, and then let me ask my user to learn Docker. Is that the experience that you want your user to go through? Or you just want them to, simple command, your model is up and available, your application is exposed and is secure? That is things that you have to start answering yourself as well as you go through this process of deploying devices, not only AI models, but any applications that you have at the moment. What is the user experience that you want to bring, right? So, as part of this is the portfolio. This is the end-to-end infrastructure that we provide here at Canonical. Open source tools, you can start using them today. And these are the tools that are helping companies like Honeywell deploying security cameras, running computer vision video analytics on the edge, on the device, in order to, again, reduce the latency. Or helping companies like RecRig doing the screening of pallets on the edge, again, identifying the objects and reducing the process time and increasing the efficiency as well. That is the benefits of bringing AI into everyday operations. So let's start with Ubuntu. Let's start with your training environment. What I want to spend some time here is telling you three easy steps for you to come up with this cloud agnostic training environment that works anywhere, from public clouds to your own hardware that you have maybe here today with you, your laptops and so on. So 3 steps. Step 1 is in one line, you can set up your Kubernetes. So we can use MicroK8s, that is a compact and portable Kubernetes distribution anywhere. And you can do simple transactions upgrades from a major version to another. It integrates with an underlying storage as well, from your local storage to public cloud storage, from an even private storage like Ceph, and also helps you with an easy interaction with your networking layer. One simple command, as you can see, and you can get your microcades up and running. Second, you can also enable this environment that you just created, your containers that are running in your cades, to have access to the GPU. Simple, by one command, as you can see there on the screen. And this, of course, will help you the moment that you're working with NVIDIA GPU operator, or even doing the GPU slicing, as you can see on the picture. Again, one command. And finally, we can install on top of that the different MLOps solutions that are available today, that you are experiencing today. So you get this nice environment for the training of your models. You can start adding Jupyter Notebook, you can start adding VS Code, different automations pipelines, using some of these libraries that are optimized for the deployment of edge devices, like what it used to be called TensorFlow Little, and Execute Torch, and other tools that are available, again, that have been built around the Ubuntu ecosystem. And there's a community and there's support available from these projects. This brings you, like we were saying, that portability, to move from public cloud to your own GPU cloud, to move from one cloud to another, and it's portable, and it's multi-hybrid support, and again, allows you to scale as you are doing this from your small team located in the UK, or even your distributed organization across different continents. Okay, that is one of the tools that we offer on the side of the development. Once you have created your applications, once your model is ready to be deployed, at the end of the day, your model is a file. It's a bunch of binaries, ones and zeros, a specific file format, okay? It's the moment that you need to package that. And for that, we have created a Snapgraph. A Snapgraph is the tool that helps you create snaps, our packaging solutions. What are doing snaps are bundling all the dependencies into a single package that is going to be running in its own sandbox. It's going to be running in isolation, okay? And it's simple to install and simple to update. So if today you probably already have interacted with snaps, if you get your nice laptop out and you put sudo snap install Firefox, you will be able to install a package that is bundling all the dependencies in order for you to run that application. Now, think of that simple concept. I created this AI model, I created this application, and I just want to give that easy user experience to my customer. Sudo snap install my application. As simple as that, you are bringing all the dependencies that you had, that you were using back in step number 1 in your Ubuntu environment, because snaps bundle all of these applications. So it doesn't matter if you were creating this application in Ubuntu 20, 22, 24, it will take everything that is needed, the Python version that you use, the CUDA version that you use, and so on, in order to create this bundle, okay? But snaps are not only about the packaging, it's also about the bundling of the dependencies. It's also about the security that it brings, okay? For example, when we're working with Docker, there's the concept that Docker was built for the cloud, was built for elasticity, and your Docker container really doesn't care what is the underlying hardware, right? Docker doesn't care whether you're running on a Raspberry Pi, an Intel NUC, or anywhere else. Like that is not the concept of Docker. So if you want Docker to have access to, let's say, USB, to GPIO pins, to the Bluetooth, there's basically 2 ways that you can do this. And people that have some Docker experience, please tell me, which is the option that you normally go? Do you give your Docker container privileged access to the host system? Or do you start going one by one and giving granular security access to your Docker to only the specific things that you GPIO pin, for instance, or the home directory or the network? What option do you normally do? Full privilege, or you start writing up your rules? Raise their hands, people that are doing option A. Come on, it's okay. Don't be ashamed of that. It's fine. It's fine. And why you do that? Because it's the easiest options. Writing those granular security rules for each hardware component takes forever. You know that. And you might even miss a few rules. So that's why most of the people, when they need their Docker container to interact with the host system, they go with the privilege flag. And by that, you are saying goodbye to the sandbox, right? If there's a vulnerability there in your Docker, now has access to everything that is in the host system. So the confinement is gone. In contrast, snaps, while they're bundled in dependencies and while they are making your application run in its own sandbox, they also come with interfaces, with these rules that allow your snap to access securely some of the system resources. So for example, again, if you want your snap to have access to the GPIO pin, there's a GPIO interface for you to declare that my snap is going to use GPIO pin, or my snap is going to use sound playback or recording or network, or my snap is going to have access to the home directory. There's even an interface that is called Power that allows you, application that is packaged as a snap, reading and setting up the system power settings of the device that is running on, and which I think is pretty cool. And again, these are some of the hundreds of interfaces that we, Canonical, maintain. So you just simply have to use them in order to give access, again, to your applications, to the host in a confined way, okay? And in addition, Snaps allows you to leverage a lot of tools that are key for the deployment of software today. From things like back and forward revisions, or automatic rollbacks if something goes bad. For example, you could be updating your edge device, and there could be a loss in the connection, or there could be a loss in the power. What happened then with your device when you boot it? Is it going to be broken? With Snaps, you always save a copy of what you are updating on the system in order for it to roll back automatically to that version if there was an issue. Okay? So that is a great feature. It's a great feature that you didn't have to engineer. It's a great feature that today is used by millions of users that are consuming Snaps as well. And I want to spend some time talking about Delta updates. Because as we mentioned, when you have a fleet of devices, normally on the field, they are using expensive satellite internet connection, or LTE. And the data costs are huge when you are, again, updating models that are big, or just updating applications that are big. With Snaps Delta updates, what you are getting is that ability of only updating those binaries that have changed between two revisions. So you are literally as a compression system that allows you to take what is currently Snap A, currently on the system, what has changed with my new update here, and only transmit those binaries that have changed. And this, of course, helps you save bandwidth and cut costs. Companies like Rigato or Dell have been using this system to reduce almost 60% of their bandwidth costs. And it takes you back to the same philosophy that we have been discussing. You didn't have to come up with this infrastructure. This infrastructure is already available today for you to leverage. This infrastructure is used by millions of users, so why you don't use it as well? And that takes us to the distribution channel. You probably have heard of the Snap Store. The Snap Store is a public repository for Snap's application. You will find things there like Firefox Snap, VS Code Snap, Spotify, and so on. But you will also find some snaps that are used for devices. This is a company, a Husarian company, making industrial autonomous mobile robots for different applications. You can imagine them working in warehouses, working in agri-tech, and so on. So today, if you go to the Snap Store, you will find all of these snaps for the navigation of the robot, for the teleoperation of the robot, and so on. Their devices on the field are consuming those snaps that are being hosted already on the Snap Store. Your device could also be doing the same. They can be pulling those updates directly from this public repository. And the process is pretty simple. You build a snap, you push the snaps to the store, and then the robot on the field is going to ping the store and ask, hey, is there an update available for me? Yes, no, and you update it, okay? What about if you don't want your application to be in a public repository, but you want it to be in a private repository, where only the devices that you have created will have access to those applications, to those snaps. Okay, that is the concept of a dedicated Snap Store. That allows you to create your private repo, where you will host your private applications. Companies like, I think that a great example is what Bosch Rexroth is doing with their Control X unit for automation. Because you will find that Bosch Rexroth was able to create an app store for their hardware through this concept, through this great concept. And with that, they are offering things for real-time processing of robotics. And they have a set of applications available for that. And they have a community that is contributing with that as well, creating new applications as well. And all of these can be done separately from using our branding, using our color. You don't need that. If you don't like the orange color, it's fine. You can bring the branding that you want. People will not see it. And of course, it comes with some great utilities like proxy deployments for connected or air-gapped environments. So you don't need to be connected to the internet, but still, you can leverage this infrastructure for updating snaps. And as you can see here in the picture, with snaps, you have different channels. You have different revisions. What is going to allow you to, for instance, my set of testing devices in my lab are always going to be consuming from the beta channel. My production devices are always going to be consuming updates from the stable channel. There's this concept of progressive releases. Once you want to make a deployment, a live deployment, first of all, you never make an update of units on the field without testing them in your lab. Please, always test. And the other great thing that you can do with progressive releases is that you can say, OK, I'm going to release what is unstable today, but I'm going to start doing it 20%, a small fleet of device, to see what is happening, to see whether or not I'm getting failures, regressions. And if that 20% was OK, I'm going to expand to my 50% of the base, my 80% of the base, 100% of the base, and you are able to update in a more secure way. Same topic. Do you want to build that infrastructure? Or do you want to spend more time creating your application? Finally, your operating system. Your production image, Ubuntu Core. Like I was telling you, Ubuntu Core is not something that you download. Ubuntu Core is the final step in your production. Once you have created your application in Ubuntu and you have packaging using the snaps, it's time for you to start using Ubuntu Core. It's time for you to create your core image. If you look at Ubuntu Core, you will find 5 elements, but today I want you to focus on these 3. So on the bottom layer, you will find the kernel. Imagine that here is a box. There's a contrast problem with the slice. The kernel that is packaged as a snap. Okay? So in Ubuntu Core 22, the kernel is the same kernel that is using Ubuntu 22.04 LTS. In Ubuntu Core 24, the kernel is the same kernel that it was using Ubuntu 24.04. All of these things, and the same applies to this minimal OS layer. It's a subset, those minimal requirements of packages that you need. Like I was giving you in the first presentation, the comparison in terms of size, that are coming from the LTS, the respective LTS. And all of that means that it's using the same kernel and system libraries in order to help you go from development in Ubuntu desktop to production in Ubuntu Core. And on top of that, you have your applications, your AI recognition image, your teleoperation snap, your navigation snap, and so on. Okay? The way that you use Ubuntu Core is that you create your production image, and for that you have a model assertion. It's a JSON file. It's the recipe, in other words, where you are going to start specifying, I want to use this set of snaps. I want this kernel. It could be, for example, PC kernel for Intel deployments with Core 22, and my snap that I created called, I don't know, successful snap 1. And that will be the recipe for you to get your image out of using a tool called Ubuntu Image. Ubuntu Image is a tool that generates image, and the only thing that you have to give it is that model assertion, that declarative file telling the tool, how you need that image to be built. Okay? This is an example. So, Nano Owl is an NVIDIA optimized model for real-time image recognition using a beautiful query system where you can add what you want the image to recognize. All of this is happening real time at the edge. So you can package your model with your Python script, for instance, that is taking as an input the video stream that you have access thanks to a interface, making your life easier and more secure. And you package that as a specific snap. You can as well package separately your CUDA runtime as another snap, because again, that will allow you to decide when you update what and at what time, right? You can update that separately from your model. And if you want to bring device management, you can have a separate snap called, for instance, the landscape client that will give you access to landscape, as we were discussing in the previous presentation. And because we want to make your life easy, Ubuntu Core comes with all of these nice security features as well, like secure boot, full disk encryption, app armor for enforcing kernel confinement, and so on. And all of these tools allows you to not only be compliant, but also allows you to bring more secure deployments on the field. A recent pen test that we did with Ubuntu Core show us that we have a robust infrastructure that set us aside from other competitors, from other operating systems available as well for edge deployment. And this is something that we are really proud about, that we constantly work with each core release in order for you to actually tell your users, yes, my device is not only compliant, but your data will be secure. This is your infrastructure. This is what is available for you today. If you want to learn more, take a picture of this. The blog on the left side will tell you how easily you can package an example of a TensorFlow little application in a snap, of course. And the second one will tell you how you can use AMD's FPGAs to deploy as well with the snaps some AI inference applications. Two different examples that will give you a nice picture of how you can use our tools today. I think that we have time for 2 minutes for questions. So, any questions? Please.
So I guess many of us are kind of like stuck in one of the major clouds like Azure. So how does all this integrate with if you're deploying from the Azure today?
Perfect. So if we jump here, where was it? Yeah, here. Here we're talking about the landscape client. It will give you access to the landscape server. With Azure, we have also partnership in order for you to integrate their client into your Ubuntu Core image. So the only thing that you have to do with Azure, you have to go and install their client that is available in the public Snap Store. And with that, you will have access to your Azure deployment. So we have a partnership with Microsoft Azure for making it easy the deployment of Ubuntu Core devices, making it easy the deployment as well of AI models built on the Azure infrastructure. Any other questions? Do remember that this system is open in that sense, that it's not only the applications that you're building, it's everything that is available in the public store. Nothing is stopping you from using these snaps on your own application. Nothing is stopping you to use other snaps that are made by developers around the world available in your device as well. Again, the same concepts of open source applies here. Any other question? If not, thank you so much.